So we're going to be talking about graphing rational functions. So you can see rational functions in a variety of formats. However, for our Algebra 2 type purposes, we're going to be focusing on this format, where it's got a number on the top and only one x in the problem, where it's in the denominator. Now, a secondary format that you could see would be something like this one off to the right here, where it's like an x minus p over x minus q. That would require you to use long division to simplify to get to a format that we're a little bit more familiar with. So you could see something that looks like this, and all you would need to do is long divide to get from here to there. There's plenty of videos out there to show you how to do that long division if you're in need of practice with that, but I'm going to be focusing on this format today. So, a few important things to recognize. So, we use the same 3 letters in all of the different types of videos that I make because it just makes life a little bit easier. A being our vertical stretch and shrink, meaning it makes our graph taller or shorter. So that would be where our vertical stretch and shrink comes from. H, in this case, represents our horizontal translation. It always ends up showing up a little bit opposite of what you're used to. So like it shows up as x plus 2, but you're actually moving negative 2 on the graph, and that's because of the minus sign, which we've talked about before. However, for rational functions, it also serves a secondary purpose. So it's not just our translation. It also is going to tell us where our vertical asymptote will fall. Finally, k, as before, is our vertical translation, meaning moving the graph up and down. Different than a stretch and shrink, it doesn't make it taller, it just moves it. But it also is going to serve a secondary purpose of giving us where our horizontal asymptote will be. So when we're looking at a rational functions graph, generally speaking, they're a little bit more interesting visually than other graphs that you may have dealt with in the past because they have 2 sections to them. So they'll have a format that looks something like this. Now, like I said, there's a vertical asymptote that comes from H. That's right here in the middle, in between these 2 lines. Now, you've talked about asymptotes in other videos before, or maybe you learned it from me. An asymptote is a line that generally most graphs are kind of approaching but don't cross. You can cross asymptotes. I don't want you to get the impression that you can't. However, for our purposes in a rational functions graph of this type, you're not going to have them crossing over that line. So our graph just gets super close to that line. Same with our horizontal asymptote. Over here would show up the opposite direction. So they're kind of handy because they divide our graph into 4 special sections. So I've got a section over here, a section over there, down here, and down there. Now for rational functions of this type, you're going to generally be in regions that are diagonal from each other. So you won't have one above the other, they'll usually be diagonal. So that's kind of handy because that helps us figure out that if we know where one section must be, then we're kind of able to deduce where the second section has to be also because it can't be next to the one that we've already made. So that's just a little bit about what rational functions look like. Now when we're going through and creating the graph of them, I do this a little bit differently than a lot of other videos that I've seen, just because it makes it a little bit easier for me in this format. I like to start, just like with every other type of graph out there, you want to start with the interesting part, the part in the middle. So like with a parabola, we always start with the vertex because the interesting stuff is happening around that vertex. Or in an absolute value, same thing. So when we're talking about a rational function, the interesting spot is right here in the middle where we have our 2 asymptotes crossing. So I like to put your horizontal asymptote, your vertical asymptote in the middle. So I would put our h value right here in the middle. Now, because our graph has an asymptote at that spot, it will not have a y value that goes with it. I don't know why I wrote x. That's just silly. So that is usually the middle of my table. Then to get the rest of the values, I follow a specific format. So I want to get, in my opinion, 2 or 3 points on each side. Now the 2 or 3 points up here are going to come from one of our curves, and the 2 to 3 points down here will come from the other curve. So that's part of the way that I set this up. Now you'll notice that when you're really far, or not even really far away, just kind of far away from our asymptotes, all of a sudden the line gets very flat. It's not very useful. And if you get too close to the lines, it's also very flat. So it's kind of a method of finding that sweet spot to get this perfect middle where the curve is actually happening. So the way that I like to do that is I go a half a point out from our vertical asymptote, a full point out, and 2 points out. Then I do the same on the other side. So a half a point away, a full point away, and 2 points away. And then I would plug them in to get my y values. So I'm going to show you what I mean by that. So our equation will say it's y equals 1 over x plus 3 minus 2. So the first thing I want to do is find my two asymptotes, my vertical and my horizontal asymptote. So the vertical asymptote is where the bottom of our fraction is going to end up being 0, because you can't have a fraction over 0. So in this equation, what would make the denominator work out to 0, which would be at -3. So we write that asymptote as a line, so x equals -3. Our horizontal asymptote would be at our k value here of -2. So on my graph, I should have a vertical asymptote, and I like to draw these in first because, like I said, it splits the graph into kind of 4 regions for us. So vertical asymptote at -3, horizontal asymptote at -2. Once I've got those two in place, I can start to put together the rest of it. So on my table, in the middle, I like to put my vertical asymptote, so -3, and I know that's going to be an error. There's not going to be a point on that line, because if I were to plug in -3, it would be 1 over 0, which we can't do. So then that half 1 and 2 out from our asymptote would be -2.5, -2, -1. So I'm going a half up from -3, 1 up from -3, and 2 up from -3. Then I would do the same on the other side. Once I've got my 6 points, I'm ready to plug them into my calculator and get out y values. So when you're plugging these in, just make sure you have parentheses in the places that you should. For example, in this case, whenever you have a fraction going on, you should have parentheses around each side of the fraction, just to make sure that the calculator is doing the math in the correct order. So when I type this in, I would type in 1 divided by parenthesis, and then I'm going to start typing in my values. So -1 plus 3, close my parenthesis, minus 2. And I get an answer of -1.5. Then I would do the same thing, but I'm going to plug in -2 instead. And I get -1. And then I will plug in -2.5. And I get 0. Then I'll do the same on the other side. So I get -4. I get -3, negative 2.5. Now at first that seems like a really strange grouping of numbers the way it's organized, but once you start to graph it, like I said, we're looking for those two separate curves going in diagonal sections of the graph. So when you're graphing, make sure you're following your coordinates very carefully. Negative 1, negative 1.5. Right there. Negative 2, negative 1, negative 2.5, and 0. So my first curve is in this upper right-hand section. And you'll notice that when I'm creating the curve, I'm just getting really close to that asymptote, but I'm not crossing over it. At least trying not to. Then I would do the same for my other 3 points. So negative 3.5 would be right here, and negative 4. Negative 4, negative 3, and negative 5, negative 2.5. So, like I said, they should end up being diagonal, and this pair did. And now I've got a picture of what my graph looks like. We're going to try that one more time. So a little bit more challenging of a problem this time. We'll say y equals negative 3 over x plus 1 minus 4. So now I have a stretch as well as my h and k value in there. So vertical asymptote and horizontal asymptote, I like to start there. So my vertical asymptote would be at x equals negative 1, because that's what makes the denominator work out to 0. My horizontal asymptote would be at negative 4, because that's what our k value is. And now I'm ready to start my table. I suppose I should put those two lines on my graph first. So at negative 1 and at negative 4. Okay, vertical asymptote goes in the middle, so negative 1 and error. You'll notice that I generally box it in also. That's to remind me that I should not be connecting the two lines, or the two curves that I'm creating across that box. So negative 0.5, 0, and 1. So going up a half, 1, and 2 from our vertical asymptote, and then going down a half, 1, and 2. And just like before, we treat it the same way, but when we plug it in, we just have to make sure we have those parentheses in our expression. So negative 3 divided by parenthesis 1 plus 1 parenthesis minus 4 equals negative 5.5. Do the same thing but plug in 0 instead. I get negative 7. Do the same thing but plug in negative 0.5. I get negative 10. Now I'm ready to go to the other side of the table, so plug in negative 1.5 and I get 2. Plug in negative 2 and I get negative 1, and then plug in negative 3 and I get negative 2.5. So now I'm going to go through and plot my coordinates. Again, don't let it freak you out that the numbers seem all out of order and there's not really a pattern like there is with other types of graphs. It's because those two separate sections are diagonal from each other and going in kind of different directions. So don't ever let that freak you out too much, because it's actually okay. So I'm going to be very careful about this. So positive 1, negative 5.5. Like I said, it's a lot handier if you spend your time really making sure you've got those points in the right spot. You have no idea how many students I see think that they got this wrong because they graphed too quickly and weren't paying attention to where things should actually end up on the graph. And I know that this looks like it's not continuing down the way it should, but if we were to plug in another point, we would see it curve off like it's supposed to. Negative 1.5, positive 2, negative 2, negative 1, and negative 3, negative 2.5. So there you have it. That's graphing a rational function in that AHK format where it's already been divided. If you get an equation that's set up like this method does not work for that. You need to use long division to get it into this format if you're really looking for this. So if you're dealing with the x minus p, x minus q format, long divide first, and then you'll be able to use this formatting for the graph. Just a reminder, I said 2 to 3 points on each side. If you're a beginner at this, I would use 3 points just because it gives you a better idea of what that curve looks like. But if you're feeling a lot more comfortable with it and you really only need 2 points, if you're going to eliminate one, I would eliminate one of these two on each side. So the 1 out or the 2 out. Either one would be fine and you'll end up with about the right picture either way. So I hope this helps for you.